example, how is vertically stretching the graph of f of x equals x squared the same as horizontally stretching it? So remember, a vertical stretch, is done by a times f of x. Horizontal stretch is done by f of a times x. Now, I think it's a little bit confusing to use a in two places, so instead we're going to call this b. So we'll say, we're just using b to prevent confusion. So don't worry about the fact that it's not what we were seeing before. It's not the same a multiplicative factor that we saw before. It means the exact same thing. A and b are both just constants. So a and b are multiplicative constants. They're just how much we're stretching by. Whether it's a horizontal stretch or it's a vertical stretch, it's just how much we're stretching by. All right, so let's see how this works on f of x equals x squared. A times f of x, that's going to be a times x squared. F of b times x, that means b times x will plug in instead for the x. So we'll get bx in as the quantity squared. So over here we've got ax squared and b squared x squared, because the squared will get put onto both of them. So we've got these two things. So how is it that they're the same? Well, how is it that they're similar? What is the connection between them? Well, think about this. A is just a constant, and b is just a constant. So a and b are both constants. But if b is a constant, then that means that b squared is also just a constant, right? If b is 4, then b squared is just 16. So it will be a larger constant than b, but it's still just a constant. It's not allowed to vary around. So b squared is also a constant. So what that means here is in either case, whether it's vertical stretch or horizontal stretch, it just has the effect of multiplying x squared. Of multiplying x squared by a constant. So what we're seeing here, the reason why ax squared, why if we do a vertical stretch and we do a horizontal stretch, and if you go back and you looked at what we saw when we saw a vertical stretch example and we saw the horizontal stretch example, you'll notice that they actually look basically the exact same. There were slight differences, but it's the same sort of stretching going on. Because when we compress it horizontally, it causes it to just sort of squirt up vertically. And when we stretch it out vertically, it's the same thing as if we'd compressed it horizontally. So in either case, whether it's a vertical stretch or a horizontal stretch, it's just the same as multiplying by a constant. So that's why they're so similar. In actually pretty much, I think, all of the fundamental functions that we're used to using by this point, all of them are already things where this is just the horizontal and the vertical stretch will wind up having the same effect. It will do it by different amounts, but ultimately it's just putting a constant into the mix, multiplying things by a constant. The first time that you'll wind up seeing things, and right now, if you've even taken trigonometry, right now the only thing you'd see where you'd be able to see the difference between a horizontal and a vertical stretch is trigonometric functions. If you look at sine and cosine, it actually is possible to horizontally stretch those and vertically stretch those, and you'll get totally different looking things out of a vertical stretch versus a horizontal stretch. Now, it's okay that we haven't really talked about trigonometric functions yet, and you haven't seen them yet probably. Don't worry about that. That's okay. And if you have seen trigonometric functions and you've taken some trigonometry, that's all the better. So you probably are already exposed to this. But just know that later on you will see cases where there is a difference between horizontal stretch and vertical stretch. But for some other functions, like f of x equals x squared, it winds up being that there's not really a difference at all. All right. Hope you now have a good understanding of all the different transformations that are available to us. I know there's a lot of them, but if you think through what you're doing with each one, you can probably figure it out without even having to resort to the table. And these are really useful because they let us build a bunch of different functions and understand how to graph functions that seem complex at first, but are really just some basic function we're used to graphing that's been stretched and squished and moved around. All right, we'll see you at Educator.com later. Bye.